Hello everyone, my name is Marina Božić and I've been working as a software engineer for more than 10 years and I still like my job. I would like to thank our organizers, IT Connect, for giving me this great opportunity to present my topic on such an event. I must say that I'm honored to be part of such a company and share this virtual stage with such a great names and colleagues. Today I'm here as in front of Avisto Eastern Europe company for which I've been working for the past 8 years. Avisto Eastern Europe is a service-based company which is specialized in application and embedded software development, as well as quality assurance and developer operations. Today, I would like to present to you 3 techniques which can be used to improve performance from your backend application. It is highly related to the data storages and the way you fetch your data. So, first of all, you have to be sure that you understand what kind of data you want to store, what is the relation between the data you want to store and how you want to fetch your data. And there are many tools which can be used for this, and let's mention some of the concepts which are here for a while. Those are relational databases, NoSQL databases, graph-based databases, as well as time series databases. Another thing that you could do is to be able to optimize the way you fetch the data and the way you store the data. And this can be done on 2 levels. It can be done on database level or application level. Today we are going to talk about techniques which are responsible for optimization in application level. And to make this presentation more plastic, I decided to use an example which was inspired by a situation that we have once when we worked for our client. The application for a client was a distributed application based on a set of microservices with the following technical stack. We had a Spring Boot as the backend technology, and we used relational databases or NoSQL depending on the service itself, and React for the user interface. Application worked for a while, but one day a customer came to us and reported missing data on a page. And first thing to do is to perform an investigation. And first thing we did in this investigation process was to check whether data exists in the production database. So the data were there. Next step was to check monitoring tools and logs, but we couldn't find any error nor exception which was related to the customer's actions. Then we checked manually the service in production itself, and what we could find there is actually that one of the endpoints which was responsible for fetching the data for the customer's page takes too long to return a response, and this might cause a timeout on the front end side. Okay, so we checked the backend service itself. We could find there a relational database and one section of the database which was responsible for preserving the data needed for the customer's page was composed on interconnected tables with many-to-many or and one-to-many relationships. We checked what we can do on the database level, and first was to see if indexes are properly set in those tables. They were properly set. We decided to move to the application level and check the entities, which are the object-oriented representation of the database tables. And we could see there that our entity, in this case equipment usage, for all the relationship description used fetch type eager. Okay, what's so bad about previous setup? Actually, when you set eager for a fetch type in your relationship definition, no matter is it one-to-many or many-to-many, you actually imply that you want to fetch all the data from all the related entities. And simply this is like overwhelming, because it will generate additional SQL queries for each of the join. We all know that accessing the database is input-output operation, which is time-consuming and resource-consuming. Also, you can see here on the left side the JSON representation of the data which was a response from the database from the first setup. You can see there that we are fetching all the fields from all the entities, and on the right side you can see what we actually needed. So we generated additional network traffic with all the unnecessary data. Okay, the first thing we decided to use was entity graphs. And named entity graph is a JPA, part of the JPA. It is very simple. It uses nodes and subgraph to specify from which entities we actually want, from which related entities we actually want to fetch the data. And this is how it looks like. It's quite simple for implementation. All you have to do is to configure the entity graph in the entity class itself, in our case equipment usage class. And so you have to specify the name of the entity graph, attribute nodes from which or entities from which you want to fetch the data, and you can also use the subgraph which is responsible for nested entities. In our case, that would be equipment type entity, which is related to equipment entity. And what we have achieved here is a reduced number of SQL queries for about 30%, which was okay, but not enough. And the other downside of this approach was that we still had that additional fields from all the entities, and we didn't want it. So the next thing was to try with the JPQL. It is also part of the JPA, and it is a SQL-like language, but instead of querying the database tables directly, it provides us with the possibility to query the entities themselves. And this is how it looks like, and all you have to do is to specify the query in repository class. As JPQL is almost the same, it has very similar syntax as SQL, but you have to notice here that instead of name of the database table, we use entity name, and instead of columns from the database table, we are using the name of the fields. Another thing that should be done also is to create a Pojo class which will use the result of this query kind of projection, and that's all. What we achieved here was that the data was fetched in a single database access, and we were fetching only the necessary fields. So we achieved our goal, but were we satisfied? Not quite. We were thinking what more can be done there, and we were thinking about the data, how often they are going to be changed, and we realized that those set of data is mostly static. And we also realized that we knew actually that with the increased number of customer, we will have additional data in those database tables, and this will again increase the fetch time from those tables. So we had to do something more. And we decided to use cache. In our case, we decided to use Redison in particular. And this is a Redis-based cache. It has a Java library implementation. And what was very important for us, that it has a thread-safe implementation, as well as operations over methods for operations over data structures such as lists and maps. Okay, so we introduced the Redis-based cache, and the result was faster data loading. In order to do so, these are the steps that you should take. First of all, you have to have Redis instance running on a host, or you can use, in this Redison case particularly, from cloud-based services. And of course you have to import the library dependency. You have to configure the Redison client and implement the methods which are responsible for data storing and data fetching in the cache. We were finally happy with our solution, and what was more important was that our customer was happy. But however, there is always one thing that you should be aware of when using cache. It is that it is highly prone to inconsistency. Luckily, there is a solution to that as well, and that is the usage of transactions. Okay, that was all from me today. If you want to stay in touch, this is my email address, and this is the Avistos website. And I would like to thank you for your attention. Have a nice day all. Bye.